again, remember the goal of this is to talk about their probabilities. So the idea is if we can find out the probability of an event is, let's say, 40%, then we'll know that its complement has a probability of the opposite, everything else, which is the other 60%. And what you'll notice if you go back through all these examples is that we realize that using complements allows us to say the following. When we say that the probability of at least one, that's when we got complements. What were the complements? The complements of at least one was none. And that's what this formula is saying, is if you want to find the probability of having at least one of something, take 1 minus the probability of having none of those, because they are complements. So the idea is that none and at least one are complements. And so that their probabilities will add up to 1. Meaning if you're missing one of the two, you can just subtract the one you do have from one, and that will give you the other one. Why is this going to be helpful? It's going to be helpful because this probability of finding at least one without using complements is a pain, because there are usually too many probabilities. Just taking the light bulb example. When you say at least one light bulb, let's say, fails a test, it could be that the first one fails, the second one passes. Or it could be that the first one passes and the second one fails. Or you also have to worry about what if they both fail. It's a lot of different options, and you have to find all those probabilities and add them up. That's a pain. Instead of just finding the probability of getting none and then subtracting that from 1. That's a whole lot easier. So the goal is, whenever we see this wording of at least one, that's what's going to make us think that we need to use complements, and it will make our lives a ton easier. So in this first one here, I have, if a couple plans to have 3 children, what is the probability that they will have at least one girl? The key, and what tells me that I'm going to use complements, is this one thing that I'm seeing here, is at least one. And again, if I'm going to use complements, that means I'm going to list out my sample space. So let's go ahead and list out my sample space, meaning my list of possibilities. So I have 3 children. What is their probability that I have at least one girl? Well, let's list out all their options. Well, it could be that all 3 are girls, and let's work our way down. Or you could have only 2 girls, 1 girl, or you could have that all 3 are boys or not girls. However you want to write it, it doesn't really matter. So what they want me to find in this problem, let's go for this and let's see, is that they will have at least one girl. At least one girl means they could have 1, 2, or all 3 being girls. So that's a lot to find, and then turn around and add those up. And with the girls, it could be that the first 2 are girls, the last 2 are girls, the first and third child are girls. It's a lot of different things to kind of figure out all the possibilities, add up all the probabilities. It's just a pain. So what we're wanting is all of this, and that's a pain to find. So instead of finding that, we're going to find its opposite, everything else. So instead of finding what we actually want, we're going to find its complement, and that is going to be everything else, which is at the bottom, finding the probability of all 3 being boys. So what we want and what we're finding are 2 different things. So let's find what we actually don't want, the probability of all 3 being boys. So let's take a look. So the probability of a boy, 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 and I want all 3 of these kids to be boys, so I'm sticking the word "and" in here. So, what are the chances of the first child being a boy? Well, the chances of the first child being a boy it's a 50-50 chance, 1 out of 2. What's the chances of the second child being a boy? Well, it could still be a boy or a girl, so it's still 1 out of 2. And the chances for the last child being a boy is still 1 out of 2. And again, I want all 3 of these to happen, so all those ands mean I'm going to be multiplying, which will get me, if I multiply straight across the top, 1 times 1 times 1 will give me 1 on top. The 2 times 2 times 2 on the bottom will give me 8. And then the question is, what is that probability? So I would need to multiply that out. So divide that out. 1 divided by 8, which is 0.125. Now, what is this value? It's the probability of having all 3 being boys. Is that what we wanted? No. We wanted the complement, everything else. So if I've got everything I don't want, then everything I do want is the complement, meaning it's got to add up to 1. So I can just take 1 minus what I don't want, and that's going to give me the probability of what I do want. So 1 minus the 0.125 gives me a 0.875. And that's my final answer for what I did want. The probability that they will have at least 1